I did get. I'll warn you guys because I never know. I have a new computer. I say it's a new computer. It was a new computer October last year when they gave it to me. September, October, they gave me this new computer, which it's great. It's got more power and all this stuff. But the problem I had, if you were in my classes last year, you may remember this. I'd be in the middle of a meet and it would just suddenly restart. All my screens would go black. I'm like, what? What? And so everybody be in class, and so Mr. Brock would just freeze and then just disappear. And so I would have to restart the computer, get back in the meet, and then my camera wouldn't work when it came back on. So I'd have to totally shut down the computer and restart it before my camera would work. And so it would interrupt class for about 5 minutes. And it was unpredictable. And so we spent months last year with the IT department. We would do updates. Oh, there's a Windows update it needs. Oh, there's a Google update it needs. We even updated the BIOS on it before. Oh, here's another Windows update. Oh, let's turn off this setting. Let's turn that setting. And we'd try something and it'd be okay for a week or two. And then boom, it would do it again. Just totally blank out in the middle of class, restart. And it finally got to the point where our IT department gave up on it. And they said, we're going to send it back for warranty because we have no idea why it's doing this. So they took my computer in March, sent it back to the manufacturer, and the manufacturer replaced the processor on the motherboard, replaced the processor, and sent it back. And I just got it back and started using it yesterday. So this computer last year was shutting down in the middle of a meet for no reason. So if I disappear, know that that's not fixed. But so far, I used it yesterday all day, no problems. But it would go a week or two sometimes without a problem. So I'm not convinced yet that we're over that hurdle. But so I'm just warning you guys, if we're in class, Mr. Brock just freezes and disappears. Just hang on. I'll be back as soon as it lets me. So hopefully that issue is behind us and there won't be anything going forward. But I'm not convinced yet until I've got some experience with it for an extended amount of time. Once it gives me some extended amount of good use, then I'll be happy with it and say, all right, we're good to go. But so far so good. So I'm not complaining right now. All right. I'm gonna turn on the Go Guardian chat here. So if anyone needs to send a message, if you need to use the restroom, go use the restroom. Come right back. Not a big issue. But let's get into our lessons of the week. Oh, make sure you got your paper and pencil and ready to take some notes, all the good stuff. I need to launch my camera there just to show that. Increasing and decreasing intervals and extrema. So analyzing functions is what we're doing in this unit. So today we're going to read a graph like a story. We're going to talk about where the graph rises, where it falls, where it turns, all that kind of good stuff that we go over with functions. And like I say, you should have seen this before, but if you haven't, or if you've totally forgotten it, let's get some notes down today. So the key idea is anytime we're talking about rising or falling, we're talking about as we move left to right. Like when we read from left to right, we read a graph the same way. As we move, according to this arrow, from left to right, is the graph rising or falling? We see this graph is rising until it gets to this vertex, and then it's falling the rest of the way. So what we are going to learn today, we're going to identify intervals. Oh, that's intervals where a function is increasing or decreasing. During what intervals is it doing that? We're going to find relative and absolute maxima and minima from a graph. Those are two different things. We'll use Desmos, our graphing calculator, to estimate extrema. And we're going to use the correct notation. Intervals use x values. Extrema uses coordinates or function values. So we've got to figure out how to write down an interval. That's where students struggle. Even if we can see an interval, how do we write it? Pardon me. All right, let's move on. All right, here is last week's lesson review, domain and range. So with this particular function right here, what is the domain? I'm going to open the chat so I can see that. Put that in chat if you got an idea. If you remember last week, what is the domain of f of x equals negative x squared plus 4? And that is what is shown on the screen as a graph. Now, the fact that those hit the bottom of the graph, the assumption is they don't stop. They don't stop. So we could, I guess I can kind of fix that here. We could say there's an arrow. Technically, that's what it would kind of look like. All right, Camden's got an answer there. Nancy? Anyone else got an opinion on that? And I like that I'm seeing parentheses. Remember, parentheses are always used with infinity or negative infinity because we can't say it goes to this point and this is where it stops. It doesn't stop. So always use parentheses. Yes, the domain goes from negative infinity to infinity. Absolutely correct. All right, so let's get to our next question in. What is the range of this equation? What is the range? The domain was not a problem, at least not for 4 of you. Maybe try to figure out, okay, now how do I put the range? Proper way to write that. Remember, domain and range, you always do the range from the smallest number to the largest number. It's always smallest to largest. All right. See, Nancy and Camden are going to do well. They remember last week, so right on top of this. Good job, Heidi. Right, the range, we can see the arrows pointing down. So the smallest number on the range goes to negative infinity. So that's the first thing we put. We put it goes from negative infinity because we see that it goes forever downward all the way, and the largest number of the range is 4. And it does touch the 4 because we can see that is the vertex. It does go through the point 0.04. So 4 is included, and we use that square bracket. Use the square bracket on the 4. So the range is from negative infinity to 4, including the 4. Including the 4. Parentheses, square bracket. Square bracket. All right, let's see what else we have. What's the highest point you see? Okay, well, that's the 0.4, right? That is the maximum point we see there. That is the vertex. That one's a gimme. It gave it to us right there on there. And here's a question: where does the graph change from rising to falling? Where does it stop rising and begin falling? At what point? Like, this is a trick question, Mr. Brock, because it's right there. No, not a trick question. Just making sure we can identify that. You see that it does right there at that point up there, 0.4. Absolutely. That's not a trick question. The graph does change from rising and falling. And that's going to be important this week when we do intervals and talk about where does that happen. So the domain is all real numbers, negative infinity to infinity. The range is any y's less than or equal to 4. So from negative infinity, I like you guys writing it in interval notation. The highest point is 0.4, and at 0.4 is where it changes from rising to falling. All right. So the vocabulary we're using this week: increasing. Oh, let me get rid of those little marks on the screen. Increasing. What does it mean if a graph is increasing? Well, vocabulary wise, that means as the x increases, the y increases. Like, what do you mean as the x increases? Well, remember the x is this. So if we're going left to right, the x is increasing. So as we start on the left side of the graph and we move to the right side, we see that the y is going up, right? So that would be increasing. As we go, it's going up. Maybe it's just going up a little bit. Maybe it's going up drastically. But as we go left to right, we see it's going up. That's what it means if a graph is increasing. So what follows that, of course, is decreasing, which means exactly the opposite. As the x increases, the y is going down. As we go left to right, as we start on the left side of the graph, wherever the left side of the graph is, whatever they're showing us, the graph falls as we go left to right. And again, maybe just a little bit. Doesn't have to be decreasing much. It could be decreasing a lot. And there's one other term we're going to use because perhaps it's constant, right? The y is going just like that, which means it's not rising, it's not falling at all. It's constant. As the x increases, the y stays the same. The graph is flat. Those are the three big terms. And when we talk about what are the intervals where the graph is increasing or the graph is decreasing or the graph is constant, this is the way we talk about this. We report intervals using the x values. So we just say from negative infinity to negative 1, this graph is increasing. Or from negative 1 to 1, the graph is decreasing. Or 1 to infinity, the graph is increasing. That just tells us the intervals. And we always talk about the x's. We didn't say how much it increased. The y went from negative 2 to 5. We didn't say that. We don't care. We're just talking about this is when it's increasing. How much is increasing is an entirely different question. So if you're trying to figure out, do I talk about the y's or the x's? We're not talking about how much it increases, just that it does. So let's look at an example graph. So here is our graph. If we look at it, we can see obviously, oh, look, it's increasing, right? It's increasing. So we can, the turning points split the axis into intervals, right? So we have two turning points, right? Because right here, it stops going up and starts going down. That starts going, and this stops going down, starts going up. So each of these red points right here are turning points. So that really breaks the graph into intervals. Let me illustrate that here. We have an interval looking at the x right here, and an interval looking at the x. Oh, well, that one got off. Let's try that again. Right there. I'll go up. I'll do a little better. There are three intervals, right? Interval 1 is right here. Interval 2 is right here. And interval 3 over here. 3 different intervals. And so when we talk about where the graph is increasing or decreasing, we do not write the y values for the increasing or decreasing intervals. We're talking about the x's down here at the bottom. So we say this is increasing or decreasing. So as a smooth turning point, we use open interval turn points. Like we don't, when we're talking about an endpoint, like this is at negative 1, right? Negative 1. So when we write negative 1, we would say at a parentheses. Instead, we would not say negative 1 with a bracket because it does not include negative 1. It is not increasing at negative 1. It is not decreasing at negative 1. That is the turning point. That's where it stops increasing. That's where it starts decreasing. So we do not use square brackets when we talk about intervals because those points are neither increasing nor they're kind of constant. That's where it kind of flattens and then starts going the other way. So we use, if there's more than one interval, this is when we use the union. That's what this U is. That's union. I mean, this means and. And is what that means. So for this, if we want to say for this graph, And we see that's what this equation is, g of x, x to the third minus 3x. Where is it increasing? It is increasing in what intervals? It's increasing in the first interval and the third interval. Liliana's got it. She's got the idea. From negative infinity all the way over there, all the way until we get to this point right here, that's where it stops increasing. But that whole time, this graph is coming way up, way up, way up. It's increasing all of that time until it gets to -1. At -1, it is no longer increasing, right? It stops right there. So from negative infinity all the way to -1. But then if we look over here at +1, it starts increasing again forever, right? It keeps going on and on and on and on off the screen. So we have 2 points of increasing. Liliana's put those for us. It looks like this. It's increasing from negative infinity to -1. And that's what that U is. It's a union. That means put these together. And 1 to infinity. Great job, Liliana. She nailed that exactly. That's where it's increasing. Where is it decreasing at? Yes. Thank you. Nancy's applauding you, Liliana. Great job. Thank you for the support. Well, it's only decreasing in one interval, right? From there to there. That's where it decreases. So, absolutely decreasing from -1 to 1. That's the only thing. Not to infinity. It only goes down for a short period of time. So, writing an interval, how to report an interval, we use the x values. The x values. See, these are all x's that we're talking about right here. From negative infinity to -1, -1 to 1, 1 to infinity. We're all talking about this. We talk about the y's. We're just talking about the x values. So anytime I ask when is this graph increasing, we're talking about what interval. You use this interval notation, and you only talk about the x values. And that's where I see a lot of students struggle in the past, but we're going to nail that this year. It's like we're going to hammer the fact that we're only talking about x's because we don't care how much it's increasing. We don't care how much it's decreasing. We just want to know where. And the x's tell us where. So we're going to get this year a lot better than in the past because I've changed how I'm teaching this. I haven't broken it out this way before. You're going to get this. So let's look at this example now. This is f of x equals -x squared plus 4. So put this in the chat. Let me take off those intervals because they don't apply to this one. There we go. Where is this function increasing? This was the one we saw on the other page. But we're going to actually let you put this in the chat now. Oh, so we've got 2 different answers already. This is great. We got negative infinity to 4 and negative infinity to 0. Which is it? One of those is correct. Where's the interval divide at? Right there. So it is. Yeah, Liliana saw what she did. Oh, she looked at the y. It's from negative infinity all the way until 0. It stops right there. Yeah, 4 is the y. You're right. 4 is how much it increased. It increased all the way to 4. But we don't care about that. It's not what we're asking. We're not saying how much did it increase. It increased up to 4. We're just saying where is it increasing? All the way from negative infinity, way back here, all the way until it got to 0. 0 is where it stopped. Good job. Where is it decreasing? We don't need a union on this one, right? We don't have 2 different places that the graph is increasing, 2 different places that it's decreasing. This one increases from negative infinity all the way to 0. And then at 0 all the way to infinity, it's decreasing now. All right, I'm seeing you guys are getting that 0, starting at 0, all the way to infinity. This graph is decreasing farther and farther and farther and farther and farther from 0 all the way to infinity. All right. So about this, what is the maximum? Okay, that's some of the extrema. What is the maximum? And the maximum is usually given by a point. Yeah, the maximum, the highest this graph ever reaches on the graph. What's the highest point that it ever reaches? Yeah, for this one, it's even marked for us. It is the vertex because this is a parabola. So 0, 4, perfect. All right, is there a minimum? What's the minimum for this graph? If there's a minimum, you should be able to give me the point that the minimum exists at. Yeah, undefined. There's not a minimum. It goes forever to negative infinity. No, there's not. I mean, we can say negative infinity is the minimum, but you can't name a point, so there is not a minimum. So there's not always a maximum or minimum. So no, there is not a minimum. So here's our answers down here. Increasing from negative infinity to 0, decreasing from 0 to infinity. The maximum is at 0, 4, and there is no minimum. All right, let's add another terminology, another more vocabulary in here. Relative versus absolute extrema. And by relative, I don't mean your second cousin. We're talking relatively speaking. When I say relative, I'm talking about relatively speaking. I'm not talking about cousin Fred. Versus absolute. See, absolute means this is it. This is the final. There's nothing beyond this. This is the absolute maximum. This is the absolute minimum given. So a turning point is not always the highest or lowest point. Overall, that's a key word. Overall. Not always. So if we look at this graph here, it's an interesting graph. It's like 4 different graphs put together. We can have a relative maximum or minimum. Means relatively speaking. Like if I was just looking, and let me disagree. If I'm just looking at this part of the graph, I can ask you what's the highest point on the graph, right? Relatively speaking, relative to just the area between 1 and 3.5 on the x. And you say, oh, well, that would be this point right here at 2, 3. That is the maximum point. Yes, relatively speaking, if I just ask you about this part or anything beyond the x-axis, I say anything in the positive axis, what is the maximum? But that's not the absolute maximum. That's not the highest point ever for this graph because this point over here is higher. This is higher, which means this is not the maximum. It's only the relative maximum, just relatively speaking. And by just talking about this half of the graph, that's the highest point. But there is a point that's higher. So the relative maximum, it can be different. If I talk about this, I could say, what is the relative maximum over here? It happens to also be the absolute maximum. This has 3 relative minimums. Because if I say, what's the smallest point of the graph here? What's the smallest point of the graph here? Or what's the smallest point of the graph here? There's 3 different answers. Because this is the minimum, this is the minimum, and this is the minimum. But only one of them is the absolute minimum. You kind of getting the difference there between absolute and relative? The absolute minimum means there's nothing smaller. This is the absolute minimum. This is the give all, take all minimum value you'll ever find. absolutely, it is the smallest value you'll find on this graph right there. That is absolutely. But relatively speaking, yeah, I could have a couple other points I can talk about. So that's what this is saying. The absolute is the highest or lowest on the entire domain. The relative is highest or lowest compared with nearby points. Yeah, just look at this area, just the things that are near that. Okay, so don't get confused between relative and absolute. They're related because they're both talking about maximum and minimum points, but there really is just a clear difference. Absolute means absolutely no one will ever find a point higher than this on this graph. This is absolutely the highest point. But relatively, cousin Bob can find something in other parts of the graph. All right, good stuff. All right, I think you got that. So let's look at this then. So name the relative maximum and relative minimum for this graph. So put those points on there. And I'll let you define the relative maximum, relative minimum. Actually, they're actually marked on the graph for us. Put that in the chat there. What is the relative? Oh, I got a troubleshooting thing there. No, it's saying the system load is heavy. So if you see slow response time or choppy audio or the video gets a little jerky, it's just saying right now Google is experiencing a high load right now. Okay. Oh, you know what happened, so I see -1, 2, and I see +1, -2. All right, great job. Great job. It really doesn't because we're talking about two different things. It's not really the end. So I get what you mean. Put them both there. So the maximum is obviously right here, and the minimum is right here. That's the but past this, yeah, there's the relative maximum, -1, 2, and 1, -2. So where is the graph increasing? So I'm talking about increasing intervals, right? We're back to intervals. Where does this graph increase? This goes back to the last slides we were talking about. You got to think back. Okay, how did we do this? Increasing, decreasing. Got to switch it back and forth. Maximum, minimum, increasing, decreasing. All right, so a little down, so it's increasing from -infinity to -1. So it is increasing all the way till this point right here. But I see other people have done an and it's increasing from right here forever. So 1 to infinity is also increasing. So this has two intervals. This interval over here and it stops right there. And another interval starts right here and goes this way. So good job. It has two places, so we got to use that and. It's increasing from -infinity to -1, and it's increasing from 1 to infinity. All right, Camden. Does this function, oh, where's it decreasing? It's decreasing, yeah, okay. Decreasing from, we know in between there, -1 to 1. Does this function have an absolute maximum or minimum? Can you give me the absolute minimum? Can you give me the absolute maximum? Leon says no. No, there's no. But I mean, we looked. We said that's a maximum right there. Well, that's a relative maximum, right? Because I can find points on the graph over here that are higher. I can find lots of y's over here that are higher than this one, because this is just relative. Just if I just break it off and say everything to the left of that line, right? If I say just left of this line, just looking at this part of the graph, what's the maximum? Over here, there's lots of numbers. It goes to infinity forever. There's huge numbers. So there is no absolute, none at all for this graph. No absolute extreme because it goes to negative infinity and it goes to infinity. So it's like you can't name the highest point of this graph. That's when that relative term comes in there. All right, great job. So we can use Desmos or a graphing calculator. So let's do that. We're going to enter the function. We can adjust the viewing window because, like, if we're zoomed in too far, we'll only see this part. We won't see these. We can click and trace the curve to inspect the points of interest, and we can record the approximate coordinates. So let's try this one right here. So I'm going to open up Desmos. Put it over here. Come on, Desmos. And if I want to look at this function, y equals, and the function they gave us was x to the fourth minus 4x squared plus 1. Hey, that looks like the one they showed us. And we can zoom in, zoom out, make sure we see, okay, there is no more turning points. Those just go up forever. So, okay, so make sure we see that. So we can zoom in. If we want to say, okay, what is the relative maximum? Well, if we click on the line anywhere, it'll tell us the point we're at. So we can go up here and say, okay, oh, it looks like that is the maximum point. That is a relative maximum, right? But it's not an absolute maximum because there's lots of points over here that are higher. This only goes up to 1. This goes to 2 and 3 and forever. I can keep going. Both sides, there's two places on this. How about absolute or relative minimums? Well, let's see. What is the lowest point here? What's the lowest point here? Oh, it's the same. So there are two absolute minimums. One is at negative 1.41421 comma negative 3, and the other one's at the positive 1.41421 negative 3. Two absolute minimums. There's two places that's the absolute lowest point in there. So if we want to say, where is the graph decreasing? Where is it decreasing? There's actually two different places here. I'm going to go ahead and close this down. So we'll just look at the graph. We'll move it over here a little bit, give us a little room. Where is it decreasing? So let's do this. Change this. It is decreasing from negative infinity to where? Well, if I want to go back and click on that, we can see that it's decreasing until it gets to that point. We'll just round it to 2 decimals, negative 1.41. That's rounded. We'll use parentheses. It's decreasing there, right? We see that. We see that all the way down there, it's going down. But not past that point. It stops going down right there, starts going up now. That's increasing. But we also see that right here, it starts decreasing again. So we have two periods, two intervals where it's decreasing. I'll put that other point up there too. So this is where we have to use that union and from 1.41 to infinity and beyond. I know you're wanting to say that. Very sloppy 1.41. But yeah, that's right. Liliana's got it there in the chat. You're going to see it cleaner than Mr. Brock typing. But those are the increasing or decreasing, sorry, those are the decreasing intervals. Decrease. Let's put the DEC. Decreasing intervals. So then we can turn around and say, okay, where is it increasing? So it's increasing from this interval to this interval, right? From right here to right here. This is the interval where it increases. So we can say it increases. I'll put INC up here. From negative, put negative 1.41 all the way to where? It stops at 0. Because when it gets right there, it's not increasing anymore. And it starts increasing again over here at 1.41 all the way to infinity. There we go. That is the periods, intervals, areas that it's increasing. And so Desmos is real helpful too. And if you don't have the graph, you just have the equation. Come in here, you type it in, and it'll show you the graph, and you can find those areas that it's increasing and decreasing. And it'll give you, when you have weird points like that, 1.41 is an X, it's nice that Desmos will give us those points, and we can just round them off to a couple of decimals there. All right, let's close that back down. So what are the extrema? Relative maximums, relative minimums, all of that kind of stuff. And Desmos helps us identify those. These are relative minimums. They're absolute minimums. They're both, because so we would really refer to the absolute if it's both. This one is only a relative maximum, and we have the areas of increasing, decreasing. All right. Okay, whole class quick check. So put your answer in the chat. Where is this? And now you may need to open up that Desmos window. Let me put that link in there for some of you that do not have the Desmos link already bookmarked. So here, I will copy it and put that in the chat. There is the link to Desmos in the chat. A quick link for you to open it. Now go back to the problem you're looking at. X minus 2 in parentheses squared minus 3. See if you can figure out, where is that increasing? Where is that decreasing? And does it have any minimums or maximums? So I'm going to do that on a different screen. I'll wait and show you what I got in a minute. I think I need to put this on paper just so I have some notes. I need some notes for this class. So I'm actually going to draw this one. Desmos gives me that point. And I want to know, where is it increasing? Where is it decreasing? Where's the minimum or maximum? I'm going to show you what Desmos showed me. When I put x minus 2 squared minus 3, this is the graph that Desmos gave. And I can click on Desmos to give me the turning point or the vertex. I see some of you are saying that this is the minimum, and it is an absolute minimum. Let me put up my notes, just because it's always nice to have some of this down that we can refer to later. So I took that Desmos graph and I just kind of drew it with the vertex down here at 2, -3. So I can say, let's see, I'm going to put increasing. If you want to put this in your notes, if you think you might forget this later, how this works, this was a nice, easy one to graph on your notes. Increasing, I'm just going to put this little line right here, right? Because that's kind of the interval. Increasing from 2 to infinity. Right? Because we can see right there it's increasing. I'm gonna highlight that. It is decreasing. Where is it decreasing? Well, when I look at the graph over here, let me do a different color. It's decreasing from negative infinity all the way until it gets to 2. Now remember, we always use the x's. We know that it went all the way down to -3, but that's a different question. It has an absolute minimum, and you could abbreviate it as MIN if you wanted to. It does have an absolute minimum at 2 -3. At that point, that's just a point. It's not an interval. That's a point. And the absolute maximum, I'm just going to abbreviate that. None, right? Because it goes to infinity. So there's not an absolute maximum. And there's really no relative extrema. So it really does have there's not like I can divide it somewhere and find a different minimum. That is the minimum. It's an absolute minimum. So that's the type of stuff that might help you in your notes if you wanted to have that in there. If you wanted to say, okay, I need some good examples for myself. Maybe we want to remind ourselves that these are x values. Because again, when I see people get confused on that, that's where they get confused. Oh, I was thinking the -3. It decreases to -3. That's where it decreases to. That's not the interval of where it is decreasing. So always make sure you're using the x values when you're talking about the intervals. X values. So that's probably the key things to have in your notes. X values, examples of what's increasing, decreasing, the absolute minimum, absolute maximum. No, there's no relative extreme in this example. The relative, we kind of talked about the difference between absolute and relative. So hopefully that's not going to be a confusing point. So just making sure that kind of all makes sense to you. Let's get back to this. How about this one? There's another one for your Desmos experiment. Negative x plus 1 squared plus 5. So you guys are nailing this. Good stuff. Let me move my Desmos calculator back out of the way. Pay attention when typing that in. Did you notice that there's a negative out front here? All right, I'm gonna put this on the screen. What I've got. Now I have the old one on there too. I'm gonna take off the last problem. Just looking at this problem. Just showing how they compare. The old one was over there. Here's the new one. This one is very similar to the last one in the fact that it only has one area where it's increasing. It only has one interval where it's decreasing. And it only has one extrema. It has one maximum value this time instead of a minimum. It has a maximum value that we can click and see is right there. That is the absolute max, -1.5. No minimums, no relative minimums, no absolute minimums. Max is -1.5. Great. And so our intervals is negative infinity all the way up until what? -1. So that divides our interval right there. Then x equals -1. So negative infinity to that line increasing, and from that line to infinity is decreasing. All right. Hopefully that's clicking right in there. And this is like, okay, Mr. Brock, this is pretty easy. All right. Thank y'all. Some of y'all send me messages when you go into the restroom. That's great. Just let me know that, why you're not participating, that you're had to run real quick. Be right back. Okay. Oh, this is a different way of looking at this. Not Desmos necessarily, but this is a word problem. You ever thought about doing this with a word problem? Because I think I have one of these on the assignment this week. We'll look at that. So this tells us a few things. First, the graph rises from x equals -5 to x equals -2. And then it falls from -2 to 1, and then it rises from 1 to 6. So it says state the increasing and decreasing intervals, which we can do because it tells us where it rises, and identify the relative extrema. See, we need more information there. If f of -2 equals 7 and f of 1 equals -4. So I'm going to graph this out on paper just so I've got a visual representation of what it's telling me. So let me put this 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm making my graph with 7 little tick marks since it looks like that's the largest value they talk about. And then we're going to graph this out. So I'll show you what I'm doing, and then you can't see the screen when I put this up, but we'll talk about it. So it says the graph rises from x equals -5 to x equals -2. So increasing from -5 to -2. So it said, and then it said it falls from -2 to 1, from x equals -2. So decreasing, it said from -2 until x equals 1. So I know that's an area of increase, that's an area of decrease, and rises from x equals 1 to x equals 6. So I know I've got another area from 1 to 6. So I've got my intervals written down based on what it showed me on the word problem. See, I've got it rises from -5 to -2, -2 to 1, where it decreases, and then rises 1 to 6. So I just wrote those down first. And then it tells me these points exist. It says if f is -2, then the output is 7. And if we enter 1 into the formula, and we don't know what the equation is, this will give the output of -4. So if we substitute -2 in, we'll get 7. So that tells us that the point -2, 7 is part of our graph. If we substitute 1 and get -4, that tells us 1, -4 is a point on our graph. So we can graph those 2 points. -2, 7. 1, 2, and I put up 7. So this is the point -2, 7. I'll label that -2, 7. This is the point 1, -4. 1, I think I'll move my 1 over. It's kind of crowding the 0. Gotta get that a little more. There we go. 1. So this point here is the point 1, -4. So it says increases from -5 to -2. So if I want to make this graph, now this is really what I need to know. This is probably it'd be an absolute maximum at -2, 7, and we'd have an absolute minimum at I'm sorry, 1, -4. It could be relative depending on how we draw it, though. That's the only thing. We're going to assume if it's increasing from -5 to 2, I can just kind of draw something 1, 2, 3, 4, 5. So we'll say there's a point over here it increases. It doesn't go lower than -5 though. It didn't say that. It just said it rises from -5 to -2. Then it falls between -2 and 1. So it goes obviously from this point down to this point. I'm just assuming it goes straight. It could curve, but and then it rises from 1 to 6. So somewhere over here it's rising until it gets to 6. Then there's an end point there. It could look like this. It could like this. Yeah, I mean, there's lots of different ways. I just know it's rising. So I just drew a rising point. So it's asking for extrema. Where is it increasing? Where is it decreasing? And then what's the extrema? We have a maximum here and a minimum here because we know it was increasing until that point, and we know it was decreasing after that point. So we know that's a maximum. We know it was decreasing and then increasing, so we know this is a minimum. We're going to assume it's an absolute because we're not told it. It doesn't say it goes to infinity. If it said it kept rising from 1 to infinity, we would know this is a relative max. But this is a max and this is a minimum. That's the kind of information it's looking for there. It says state the increasing, decreasing intervals. Oh, okay. It does tell us they're relative. Okay, relative. So it could keep higher and lower, but we know there's a maximum and a minimum at those points: -2, 7, and 1, -4. We'll just say it's a maximum minimum. We can change it to a relative if you want to, or just okay. That's a max. That's a min. Okay, I guess it said in the question they're relative. So. But that's what it's asking for. Identify. If it helps to graph it out, you could do that. If you can just look at the word problem and understand, this comes straight from the word problem. Where's it increasing? Where's it decreasing? It might help the graph to understand these, but it gives you those points at 2, at -2, and at 1. So I think there's a problem like that in our assignment this week. We'll look at that before we leave today. Let's look at this one. All right. For each graph. So let's do the one on the left first, over here. This one right here. What are the increasing intervals and the decreasing intervals? And give any relative extrema. So right now, put the answer for this graph. Give me the, all right, thanks, Alana. Give me the intervals where it's increasing, decreasing, and any extrema, relative minimum or maximum. I'm going to write my answers down on paper. So that's one. Let's see. All right, what are you getting? Cooper's got some answers in there for the intervals. Anyone else got an answer? This is where you make sure you know what you're doing before you got to turn in the assignment. All right, some of you, I can tell, are just typing in the answer you see in the chat because you're not doing the work yourself, because the first answer in the chat actually had one little problem with it. And then you guys are repeating the same problem. One thing, always list it, it's a -1. And you always list it from smallest to largest. So we wouldn't say infinity to 1 if it was 1. We wouldn't say infinity to -1. You turn that around, you say from -1 to infinity because it's positive infinity. So yes, what I have on there, I like it. -1 is where it's increasing. And you can list the decreasing first. I just wrote down the increasing, so that's fine. You guys are doing -infinity to -1, and then -1 to infinity. But make sure you put smallest to largest. Infinity is a lot larger than -1. So left to right. And then the relative minimum, which I didn't have on there yet, but the relative minimum is at that -1, -2 point. All right, let's do the one on the right. It's a little trickier. It's got the equation for it up there. If you wanted to put it in Desmos, you could type that in there. But I think you can see on the screen where the points are, maybe. Well, actually, it looks like that isn't exactly on the points, is it? Interesting. Where's my decimals? I'm going to move that over here on a different screen. I'm going to type that equation in just because it does have some odd stuff. Oh, there is a, it's hard to see, that's a negative 0.25. Okay. Yeah, those points that they show in here are, those are a Desmos problem. Here, I'm going to put up the Desmos problem. The Desmos graph right here. Look, here is that point. Here is that point. There's where it crosses the Y, where it crosses the X. But those points, I'll put a bunch of points up there. Those are not the 0.21. Those are the 2.11963, 1.015. So you can round that to just like one decimal if you want, or two decimals. But that problem works better on Desmos because looking at it here, you can kind of see it's not really on that line. It's to the right of it, so it doesn't help us there. Oh, where am I? There we go, Desmos. So again, any maximum minimums, any increasing, decreasing. Here, I'll do decreasing first on my paper this time. Then I'll do increasing. I'm going to round them to two decimals if they don't have an exact point. Okay, I'm writing down my answers. I'm going to show it here in a minute. I'm giving you a chance to get your answers. Okay. Yeah, with Desmos, that's all. I actually threw these in there. These are kind of to throw you off. Those points have nothing to do with the maximum, minimum, increasing, decreasing. That's just the X and Y intercepts, which we don't need for what we're doing. Those are good for other things. Yeah, increasing and decreasing parts. Yes. And any max or mins. So that one helps to have the equation and put it in Desmos. So yeah, this one, oh, I'm sorry, the Desmos is what had the points because this one actually has two areas of decreasing, right? It's decreasing right here, and it's decreasing again over here. And only one area where it's increasing. So your decreasing should have two sections, increasing should only have one. And then, of course, you have a relative minimum. It's not the absolute minimum. We know it's a relative minimum because this is a lot lower. And a relative maximum at those points right there. So they're not little fun, easy points. It helps to put that one. I wrote it on my paper. I rounded it to two decimals, but negative infinity to the negative 0.79 and the 2.12 to infinity. Increasing that one interval. I did the max and then just rounded them to two decimals from what it had on Desmos. Okay. A little practicing. Common errors, things to watch for. If you said it increases from y equals -2 to y equals 5, that's wrong because we're talking about the x values. It increases from x equals -2 to x equals 5. Don't call every turning point an absolute maximum minimum, right? Because it might be just a relative maximum. Not like last one we did, there was no absolute maximum minimum. What if it said, what is the maximum? And you said x equals 4. No, x equals 4 is just the x value that the maximum is going to be like 4, 7. What is the point? If it's an extreme question, ask for the point. What is the maximum point or the minimum point? And forgetting that endpoints can be absolute extrema on restricted domains. Like on this one that I drew, I guess I should go back and look at that. If it told us, and this is one that I drew, so it doesn't really know. If we knew this was the end of the graph, this would be another minimum. It'd be a relative minimum. but it didn't tell us exactly where that point was. So we're just assuming that maybe it goes forever. So those go forever. But if we were just talking about that point that ends right there, there'd be a relative maximum over here and an absolute maximum over there. So remember that if it doesn't go forever, those endpoints can be maximums or minimums. So we'd say, the function is increasing on this interval and has a maximum, a relative maximum, or an absolute maximum at whatever this point is. So, all right, we've done pretty good covering everything. I do have, and I'm going to give you the rest of this time, I have an exit ticket. It's got like 2 questions. And I will give you a grade on this just to make sure I understand. I'm going to put this link in the chat so that way you can just click on it from the chat here. You don't have to go somewhere and find it. But let me show you real quick before you go to that where this week's assignment is. All right, where's my screen that has that? I'm just gonna pull it up fresh here. All right, so if we go to right here, go to our Google Classroom. It's loading. It's being slow. 5th period. All right, 5th period Google Classroom. If we go to the classwork tab, week 3. Oh, here's the exit ticket here too. There's another link for it right there. This week's assignment. I've got this week's lesson in there as well that we're looking at on the screen. Here is the assignment for this week. It's all, as you can guess, it's all about intervals of increase and decrease and the maximum and minimums. It's loading. I probably clicked too quickly for it. There we go. Okay. Give the intervals of increase or decrease in extremis. So this you need to go to Desmos. But here's the graph. Put it on Desmos. Get a hint. Did I put that in the hint? Oh no, I need to put Desmos in the hint. But anyway, give the intervals increase, decrease, all extrema. So these are ones you should go. Oh, here is the absolute value. By the way, when you're entering an answer in here, like I'm entering 45x plus minus x squared, and it looks like that. Now this should just be whatever. You can. Did I not do that on there? You're supposed to be able to enter a math response. How do you do the math? I've got to fix that. You should be able to enter a math response. Oh, I have a calculator available. Okay, I've got to change that where it lets you enter a math answer. Let me go in. Do I have one that sets a math answer already? Maybe not. Looks like there's only 6 questions. Increase, decrease, extrema, increase, decrease, extrema, increase, decrease. Okay. And then here, it's like that word problem. A function's defined on right here. So this point exists. Its lowest point here and has a turning point here. Which point is the absolute minimum? Because this point is there and this point is there and there's a turning point there. Explain how you would know which one is the absolute minimum. And here's what it says. The maximum is x equals -4. There's an error there. What is the error? Rewrite it correctly if the graph contains this point is on the graph. But I need to change these to where they allow math responses because they're, and I wanted to show you that. So, I mean, you can always type INF for infinity. Okay. I changed it to a math response. So I may change the other ones as well. All right, I'm going to show you this. When I click on type a response, I've got it set to be a math response now. So it opens up this extra menu. Right? So I can type in things like that. If you look right here, there's 5 menus here. These actually are 5 different menus. And this one shows an infinity. If you go to this third one, and I want to type parentheses, negative, there's an infinity button over here on the right side. Infinity to infinity. Maybe I'm just saying this one's, the domain is everything, or the increase is everywhere. That's not the answer, so I didn't put that. But there are infinity symbols there. And there's even an absolute value symbol on here. Look at that. If I do absolute value, I don't think you need that in any of your answers. But I'm just letting you know there is an infinity in here that you can use. You just have to go to the third menu. The first menu is just the normal calculator stuff. It does have an x squared function you can use or a square root, stuff like that. But formative is good about letting you put things there that look like math. Oh, if you were doing a domain and saying x cannot be 3, look, there's one of those cannot be equal signs. X cannot be 4. So you can actually type it to look like that. So I'm just showing you options you have if I set it up right. I didn't set it up right to where you can do math problems. Um, I think that, does it let me type words if I do it as a math problem? It does. Okay. I can type words. It just puts them in italics because it thinks I'm doing equations. So I may or may not leave it like that, but I think that'll work okay. So I just wanted to show you that that the math functions does have infinity symbols available for you in that. And it looks like everyone did last week's assignment. That's great. So make sure you stay on top of things. I'll let you guys do the exit ticket. As soon as you're done with the exit ticket, you can go. Advisories next. You got plenty of time. You got like 20 minutes left to do these 2 questions on the exit ticket. State the intervals of increase and decrease. And then question 2, what's the difference between a relative maximum and an absolute maximum? And again, I put it in the chat so you can go link to it. I'll mute myself if you got questions, but otherwise, get the exit ticket done and you are free to go. Have a great week. We'll see you next time.